All right, so now here's an example of our class. We now have, we've created a class called circle. A circle generally has an x-coordinate and a y-coordinate for the center of the circle, and then a radius. That's one way to describe a circle. In mathematics, there's another way to do it. But anyway, we're going to use three fields that are of type double. So we've talked about the different types. This is a primitive type double. And the x, the y, and the radius can be doubles. Now, is there anything you see almost right off the bat that's not perfect about this choosing a double for the x, the y, and the radius? So for example, can doubles be positive or negative?
I think so. I think they can be.
Okay, yeah, they can. But if we make the radius a double, that kind of means the radius could be negative. In math, there should be no such thing as a negative radius. So we're kind of opening the door, but we want to try to keep the example simple. But in this case, it's possible some mistake in some method could make the radius negative, which doesn't actually make mathematical sense. So it might have been good to have this be a type that could never go negative. But that's really if you want to be strict about the math part of this. So now we have a method that has the name that matches the name of the class. Okay? So a method that has the same exact name. So this is a method that's part of the class. It could be whatever name you want it to be, but for the method that has the same exact name as the class, that's what they call a constructor method. So when you go to create one of these objects, one constructor will run, and it'll actually run implicitly. So what I mean by that is, if in our main program we decided to create a circle by saying this, circle C1 equals new circle. What we're saying is we're going to make a reference, we talked about this last class, C1 would be a reference to a circle object. Calling new actually creates one. Now what happens when we create one? Well, first of all, a circle has three pieces of storage, an x, a y, and a radius. So we're going to create, the object's going to look something like this. We're going to have an x, a y, and an r. Then, the constructor is a method that runs during the the construction of this object. And instead of accepting just the default values for these would be 0. We have an opportunity to change them to some other number. So, for example, when we call circle with no parameters, do we have a method, a constructor, that takes no parameters? Now in this particular example we don't. So let me do this as an example. Let me make this, let me just write it over here. New circle, 1, 2, 3. Okay. We've created an object. We're creating a brand new object. We're going to put the reference C1 to refer to this object. The object has three fields in it, an x, a y, and an r. If we don't do anything, the values will be initialized to their default values, which is 0. But we have a method here that takes exactly three parameters, an x, a y, and an r. Let me make this a capital R. Okay. Now, the parameters I'm passing in as 1, 2, and 3. So, they're coming in as x, y, and r as global parameters to this method. We now have, you might be seeing this for the first time, but you have this variable, which refers to the object that this method is being bonded to. So this is the constructor for this particular object, so it means this one. So this is an implied reference to the current object. Whenever you are calling a method on a particular object, by default, implicitly, the keyword this, THIS, refers to that object. That is another reference to that object that you get for free. So, this line right here is saying this x, meaning this spot, is equal to the variable for this parameter, which is also x. Now it might look confusing, and it would have been probably smarter to call this A, B, and C, and then say A equals x, and B equals y, and C equals r. But that would have been very clear. I just want to show you that you can do it this way. So now what we're doing is we're saying that the parameter that came in under x gets written to this location. So the 1 gets written here. This is now, what I'm doing with the pen is what the constructor method is doing. So this object has not been completely constructed yet. This function here, new, we're creating a new object and calling it with this constructor, the one with 3 parameters. This function here implicitly calls this function. So what would an implicit call to a function be, as opposed to an explicit call? Has that ever come up before? Well, when you explicitly call a function, you call it by name, right? If you want to know the radius of a circle, you would say, you know, c1.radius. So you're calling the function radius, just saying it by name. Implicitly means you don't give the name. Some function called it for you. So in this case, we did not explicitly call the circle function. The new called the circle function for us. Okay, so now a 1 got written here. This 1 parameter was loaded into this x variable, which then got copied into this, which is this piece of storage. This is x field. The next line, the y got copied over, 2, and then the r got copied over, which is a 3. So what we really have is a circle, and you could imagine it like this. The x field is 1, the y is 2, and the radius is 3. That would be, so the circle looks something like this. Right? The center is 1 and 2, and the radius is 3. Now the only thing that we have in storage is these 3 fields. This is just like in our mind. There's no actual circle anywhere in memory. And then we could create, if we wanted to, after this is now done, we have, what do we have here? We have another method, and I'll get to what this public thing means in a second. So just ignore the public for a second. We have another method called circle that only takes 1 parameter. So when we executed this line of code, why did we pick this method to run and not this method? Because now what we really have, we have an interesting situation here. We have 2 functions that have the same exact name as each other. You would think that shouldn't be allowed. And why would you think that would not be allowed? Like, your intuition might think it wouldn't be allowed.
Which method would it call on if they both have the same name?
Right. There would be confusion if you went to use it, like in this case. If you went to use it, you don't know which one to use. But there is a difference between these 2. One of them has 3 parameters, and one of them has 1 parameter. So as long as the code that was calling it, you could distinguish which one to use, then they would let it happen. So this is where this is called a method overloading. meaning we've taken the same method and we've given it many versions of the same function. Now, if you think about it, that's always been the case. Like, for example, the plus, right? A equals B plus C. The plus is a function. It takes in two parameters, B and C, adds the result, and stores it in A. If these were both integers, you can add two integers together. If these were both doubles, you can add two doubles together. It's the same function, but it works with different objects. So the plus function, as you know, you can plus many things together. It's not just tied to one type. So this is an example of something you use many times. This is an overloaded function. We're kind of doing the same thing. So suppose now we decided to, again, what's in purple is like in the main part of your program. Suppose we had another circle. Circle C2 equals new. Circle 4. Now I'm calling circle with one parameter. Okay, so now the question is, out of all the circles we have, and if you think about it, we could actually write infinitely many circles, as long as the parameter list is something different, something unique. We can write as many as we want. So here's the version of circle. We are now obviously trying to construct a new circle item. So we get a new piece of storage. Its name is, the reference that's being bonded to this piece of storage is C2. And then by default, THIS is always referred to once we're inside a method. Once we are inside a method, THIS is a reference to that object. Once this constructor ends, this goes away again. Okay, now, we are constructing a circle, the second circle, which we're going to call C2. And we're just passing in one parameter to the constructor. So there has to be, of all the constructors we have, and like I say, we could have infinitely many, there can only be one that takes in one parameter. And that happens to be this one. So the public circle, the one that just takes in one parameter, the radius, and here's the whole body. And what I did, hopefully this doesn't look too confusing, I wrote 1, 2, 3, 4 lines of code, but I wrote it all in one line. Because as long as you have a semicolon, you could all write it all in one line. It's just a different style, but I wanted to have it all fit on the whiteboard here. So when you give one parameter, it gets passed into the R variable. Our X and Y automatically become 0. So we get a piece of storage. The default values of 0, 0, 0 get written in. Then our constructor runs where we can alter the default values. And we now say X equals 0, Y equals 0. So that really doesn't do anything. This, now remember, during this method, this is another reference to this particular object. This R is equal to the R that was passed in. So the R that came in was 4. Okay, and now I should have done something before. We have this variable called number of circles, num underscore circles. This variable is a static variable. Now, a static variable is you get one piece of storage for the entire class. You don't get one for each circle. Like this is a circle and this is a circle. Then there is a circle, we'll call it circle dot num. There's one piece of storage for the entire class. There's not one, like, this circle has an X, a Y, and an R. This circle has an X, a Y, and an R. Every circle is going to have its own X, Y, and R. But the entire class will only have one variable called number of circles. There'll be one for the, so we're not going to have this. We don't have number, num circles and num circles. We don't have one for every object. We just have one variable for the whole class. An example of that might be if we've decided, a simple example would be if we had a counter, counting up how many circles have we created. So, let me just go back to this first constructor. We filled in x, the x parameter, the 1 got copied into the 1 field. Well, wait, hold up. When the class originally got loaded, we initialized this variable to 0. So that would be before any of the class objects started being created. This field, where there's one variable for the entire class, that was set to 0. Now, subsequently, we can change that method. We could add 1 to it, subtract 1. But in this case, when we created the first one, we copied the x value 1 into this field, then 2 got copied into this field, 3 got copied into this field, and then the static variable, num circles, was, we did a plus plus operator. If you remember, that means add 1 to the current value. So this became 1. Now we went to create the second object. We go to create the second object, which passed in only one parameter, the 4. So that forces us, out of all of our constructors, we could write as many constructors as we want. We have to find the one that matches, the one that takes in one parameter. So that's this one. This one made the x field a 0, the y field a 0, the parameter that was passed in became the r field, and then the static variable meaning 1 for the whole class, the static variable num circles gets incremented again. So this now becomes 2. Okay. So now, this class also happens to have some methods associated with it. For example, there's a circumference method which returns 2 times, this looks like pi, right, 3.14, times the radius field. Okay. And then we have another method, which is public, returns a double, and it's called area, and what it does is it returns, this looks like pi again, times r. So that's like pi r squared. Right? So, suppose we decided to now say C1 circumference. We're going to need a variable like x equals so if we did this, we're saying for object C1, that's this one. For this object, call its circumference method. So take this object, using this as your data, call the circumference method. So this is object C1 dot, and then the name of the method. The circumference method is a public method. We'll get to that in a second. I'm sorry, where are we? This one, it's a public method. It returns a double. So after it's done doing whatever it does, it expects to give a double back. So you need a double to receive it to. So that's why I have this variable x, which is a double. I declared x as a variable, which is a double. So now we have x is a double. And by default, it got set to 0 when we declared it. This is, like we said last class, this is a primitive type, so when you declare x, you actually get a chunk of storage named x. It's not just a reference to a chunk of storage, you actually get one. And then if we said, okay, x equals c1 dot circumference, that means go to this, using this object, run the class method, object method. Run the object method circumference. And what does circumference do? Well, circumference returns 2 times pi times r. So what is r on this one? 3. 3 times pi, that would be 6 times pi, which is around 18.8 or so.
Probably 19.
Around 19 or so?
19 point something.
19, okay. So this will come back, this will turn into something like 19, right? Okay, so that's what this line would do. So now what we're doing is we're saying, using this chunk of storage as the object that we're interested in, call the circumference method. The circumference method takes in no parameters. And this circumference method takes in no parameters. If we wanted to, we could start adding more circumference methods passing in parameters, but generally circumference gives you an answer. It just tells you what the circumference is. Okay, now suppose, using this class, the class that's in red, we wanted to get the area, let's say we wanted to get the area of C2. X is equal to C2 dot area. So that says go to the object C2, which is gone now because that method stopped, the constructor method. So that's no longer a reference to that piece of storage. And if we go to C2's area function, area will be a function that takes in no parameters. When it's done doing its computation, it expects to give back a double. So we will be giving back a double to this. So that should not have a compiler error. And what does this function do? It has one line to it. It returns pi times r times r. So I should have used a smaller number. Okay, so the r is, the radius is 4. So 16 times pi is what? 16 times
49.
48, and then 0.14 times 16, 49, 50, I don't know, around 50 or so?
It's 50.24.
50.24? Okay. So that'll be 50.24. And it's a good thing we made this a double so we could take on real values. 2, 4, right? Okay. Now suppose hypothetically I decided to, so again, what's in red is our class definition, and then this is like in our main program, making calls to that stuff. Suppose I did this. What would happen when you went to compile this? Like what am I actually asking for? I'm saying take object C2, call its area function, passing in a parameter of 4. What would it do? We only defined one area function, and the one we defined doesn't take any parameters. So what could we do? What could the compiler think to do when it sees that 4? Like right now I'm just talking about the idea of calling functions and making sure that the compiler can we're given the opportunity to write many versions of the same function as long as, like you said, the compiler can figure out which one you're calling. Could the compiler figure out what to do with that 4? Or if you were designing the language, what choices do you have? Could you say, well, we don't have an area function that takes in a number, so I'm just going to ignore it and call this one. Would you say, oh, the programmer gave us a 4 that he or she must have made a mistake, so we'll just get rid of the 4 and go on? Or would you say, no, this is a compiler error, you need to figure out what you're doing wrong, right? So that's what they'd end up doing. In this case, you have to make sure that this is what they call this function signature. They're saying that the signature, which kind of uniquely identifies it, is the combination of the name of the function, all the possible parameters you could give it, and also what it returns. So in this case, we return a double. So you have to have a unique signature. You have to have a function that uniquely matches what's going on here. This function is expecting to return a double, because x is a double. So we need a function that returns a double, which is this. And then, which is this. And then we need the name of the function to be area. And then the only one we defined is the one that takes in no parameters. So this would cause a compiler error, this 4. So we have to have no parameters in this case. Okay. Now suppose, let me make a little more room. Let me write our storage down here. C1 is 1, 2, 3. And our circle number of circles is currently equal to 2. Okay. Okay, now suppose we decided to do this. I'm making a third one. And I'm passing in no parameters. So this might kick off, you might right away get the answer right, but in C++ you'd get the answer wrong. But anyway, what do you think would happen here? It looks like we're trying to create a third one. It looks like we're trying to create a third object called C3. We're calling a constructor that takes in no parameters. We have a constructor that takes in no parameters. No, we have 2 constructors. One of them takes in 3 parameters, the x-coordinate, the y-coordinate, and the radius. Another one that takes in just the radius and by default puts the circle on 0, 0. And we don't have one that takes in, we don't have one that takes in no parameters. Now so what would you think would happen here? Would it be a compiler error? Or do you think, this turns into an interesting discussion, do you think that every class should have, by default, a constructor with no parameters? So in other words, could you define, what would you do off the top of your head if you wanted to have a rule that says every class automatically has a constructor that takes in no parameters? What would if they don't, in other words, if the developer doesn't write one, could you think of what it should do? Because think about it, all an object is a bunch of fields. every primitive type has a default value, right? We covered the last class. Whether it's a Boolean would be, what are Booleans? False by default? I forget. But anyway, every field, a double, a float, they all have default values. And then if you start creating classes, all you're doing is creating classes of primitive types plus other defined classes. So they all eventually go back to a primitive type. So every field has a default value. If you create an object and you don't give a constructor for it, could we make the argument that the constructor with no parameters should just fill in all the fields with default values? Because really, let's think about this. What is the point of a constructor? You're already getting the storage filled in with all its default values. Now, the body of the constructor is your opportunity to change those fields. If you left it blank, it would just be whatever the default values are. So could you make an argument that every class should be given for free by the compiler a constructor that fills in all the fields with default values? And basically a constructor that does nothing. In other words, should this be a compiler error because we gave it no parameters and there are no constructors with no parameters, or should the language be nice and say to us, okay, just fill in everything with a default value? Can you think of any argument to allow that or not allow this? In other words, if you were designing the language, would you make this a compiler error and tell the person, you got to write a new method for us because we're not going to accept this? Or would you say, okay, the person's giving me no information, so I'll just fill in all the fields with default values?
Yeah, because you have two already, there are methods there, you don't know which one is going to use it to fill it in. Fill in
Well,
the parameters. You gotta,
well, you're saying out of this call, it might call this one or it might call this one, and we don't know. Well, no. What I'm saying is this is unique only to constructors, because by definition, if you don't give any information, generally we don't know what to do. For regular methods, we don't know what to do if you don't pass in parameters, and we don't have a method that takes in no parameters. Because we don't know if we were to pick this one or this one, we wouldn't know what to fill these values in with, because you didn't give us any information. But what's unique about constructors is that if you don't give us any information, we actually have a default behavior, and the behavior is just fill in all the fields, because all the constructor's doing is initializing the fields. So if you don't give us any information, we could make the argument, all right, I'll just fill in everything with whatever its default value is. You know, strings could be blanks, and numbers could be zeros, and booleans could be falses, whatever the defaults are. So you would decide that this should be a compiler error? Or would you fill it in with would you give every class an automatic free constructor that takes in no parameters and then fills in all its fields with default values? So the answer to this question in C++ is they allow this. This will fill in all the fields with default values. Java decided to not allow this. So what Java does is this. Their rule of thumb is this. If you do not supply any constructor at all, you get the default one for free. If you give, these are all optional. We didn't have to write these. If you do not give any constructor at all for free in Java, you get the one where if you give it no parameters, it'll fill in all the fields with defaults. But in Java they have a rule that says once you declare any constructor at all, you lose the free default one. In C++, you keep the free default one forever. But the creators of Java decided that once you write any other version than the default one, the one that takes in no parameters, once you do that, you lose the free one. Now you'd have to go back and write the free one. So if we wanted to write the free one, what would it be? So this is one thing that's a little annoying about Java, because we wrote this special, we have two special ones, because we want people to be able to say, give the x, the y, and the radius. We'd also like people to be able to just set the radius, and it'll make the circle be on, you know, it'll be centered at the origin, and just have like a radius of 4. But we'd also like people to just create a circle, and not give any information and get a free circle. Now, off the top of your head, what is the definition of a default circle?
The unit circle?
So that would be at the origin with a radius of 1.
Radius 1, yeah.
Okay. Now, where did you get that from?
That's us.
I mean, is that like something you... I would guess that, but is that like by...
No, that's what we went over in like Calc 3, we went over that, and that was the default circle, was a unit circle radius.
Okay, there is such a thing in math as a default circle?
That's it
Yeah.
right there.
Okay. There's an official definition in math called the default circle?
I don't know if it's an official definition, but...
Oh, okay. So if we wanted to have a default circle, in other words, let's say we wanted people to do this, what do we want? We want a new piece of storage called C3, and we want it to be 0, 0, 1. So, and then we want this counter. Let me move this variable over here. So here's our storage, and we have circle, num, circles. Now this is currently set to 2 because we're keeping count of how many we've created. Now if we wanted to write the body for this version, what would it be? We would need a public, we'd have to go public, we're not returning it, public circle, no parameters. This x equals 0, this y equals 0, this r equals 1, and then increment the counter, right? Actually, we don't have to use this because this gets rid of the confusion, this x compared to that x. There is no parameter, so we don't even need it. We can do this. We can say x equals 0, y equals 0, r equals 1, and num circles add 1 to it. And that would be the whole body of it. Okay, so what would happen? We'd create a third piece of storage, put a 0, a 0, and a 1 here. Right? And then, so now we have this program that we're putting together here has, this is all our storage. We have C1, which is x value is 1, y is 2, radius is 3. X2 is another piece of storage, an object, a circle object. X is 0, y is 0, radius is 4. Now we've created a third one, C3. X is 0, y is 0, radius is 1, because we've decided that's the default for a circle. And we've made the counter, the overall counter, go to 3 now. So what if we decided to, what if we wanted to now print out how many circles do we have that are out there in our storage? I should have left some more room here. How would we print out? You know, obviously it would be system, what's it, system.out,
Yeah.
print line, print. And what would we print? I just want to print this thing out. Would I say like, would I say C3's num? Would that work? because it's not really connected to C3. It's a static variable, meaning one for the entire class. But this would actually work because it's like all three of these objects are sharing that field. So that would work, but you could also just say the class name. You could just say circle, meaning give me circles, number of circles. Either way, you could print it out. But like I say, we're separating this because it's a static variable. Because it's a static variable, we're separating it from each of the objects. There's just one piece of storage for the entire class. So then if you were asked like one of the common, I don't know if it's a trick question or, but a common question about storage, like if you had a class like this and you created 3 objects, how much storage did the whole class take up? So the way you'd solve the question is say how many individual fields are there? So there's 3 doubles, and then how big is a double? Times 3, and then there's 3 of those objects, so it'd be that number times 3, and then there's only 1 integer. How big is an integer? There's 1 integer for the whole class, and then you add it all up. That's a question like that. Okay, now suppose, just now that we're getting used to this idea of having a static variable, we used this pi 2 times. And this isn't the greatest estimate for pi, right? I just used 2 decimals. Someone might come along and say, oh, you need more decimals to be more accurate. So what if we changed it in one place? Like we corrected it here, but we forgot to correct it here. Now we got like 2 different pi's. That's not a good idea, right? So is there a way we can have 1 pi, and then if we ever change it, it gets changed everywhere? That would be nicer, right? So what we'd like to do is have a variable. Maybe we could have a static variable for the whole class, right? So what would we do? We could say,
PI equals.
I should have left more room.
No, actually, pi could be a final.
Well, that would be a good, yeah, so I was going to get to the final thing. So let's see, class circle. So let's have pi, what would we make it, a float, a double? All right, let's make it a double, just in case we want to get really big with it. Would you make it a static, meaning 1 for the whole class, or would each object have its own pi?
No, just make a final. Make it a final.
Right, but if we declare it inside the class, all the objects are going to get its own copy, unless we say static, meaning 1 for the whole class. So would we want to make this one static? Yeah, we'll take up less room this way. I mean, we could have, each one will have its own copy of pi, but we can make it static. Now, what we wouldn't want is one of these methods, you know, some programmer goes and changes the value of pi. That's no good, because now it would change, well, it would change for everybody. So what we'd like to do is we're going to declare pi's value, but we want it to make sure it never changes again, because pi doesn't change, right? There's only 1 pi. So we'll say static, we'll make it a double. Wait, we want to say final, meaning it can't be changed. And it's a double. And we'll call it pi. Now, because we made it final, meaning it can never change, we have to give it some value. Think about it, if you didn't have to give it a value, and you made something a final, what compiler error would you think you would then get? Like if we did this, if we said pi, end of story, we never gave it some value. Well, if nobody ever uses it, then what's the point? Right, we declared a piece of storage nobody's going to use. If someone uses it, it has no value. So you're going to get some error like value may not be set before it's used, you know, some kind of compiler error like that. So we have to, is anytime we say something is final, meaning it can never, I'm setting the value now and nobody should ever change it, we obviously have to set it. So at this point we can say 3.14. Anyone know what comes after 4?
1, 7.
2 or 3.
What, 2, 3?
I think
think it's 14117.
That sound right?
3142.
142, well, what was it, 22 divided by 7? Is that pi? Is that pi exactly?
Yeah, 22 seconds.
So what is that?
I got 3.14159.
Okay.
3.142.
Okay, so now, if somebody decides, like after we wrote all our code, oh wait, so now instead of using this, we want to use pi. Now, if we decide our pi wasn't good enough and we need to make it go longer, we just change it in one spot and these are all fine. This now uses pi and this uses pi.